fact, they even worked pretty hard where so they had false, of course, as well. And this is 5 characters, this is 4 characters. So they even padded that out to 5 characters to make some sort of comparison more easy or something like that. And anyway, so they're thinking hard about how to make true and false in their system. And really, of course, where was the error? It was not the computer no longer interpreting true and false properly. It was their code had some error in it. And this belief that the computer was wrong was preventing them from finding that error. So, these problems are hard. I'm not denying that. But don't get to this point where you start to believe conspiracy theories as opposed to there's something wrong with your code, right? So I'm picking on a few people in my emails here. So I had someone believing that new int 10 was putting a number 9 in the last spot, right? And we had like 4 or 5 emails back and forth trying to prove that that wasn't true. And in fact, we just proved that it wasn't true. There was a mistake in his 2-string code. So what he was printing out was wrong, right? Someone else said, can't find the .text file in the project folder. Well, I don't really understand what happened there, but their project folder was like A5, and then there was like another A5, and then there was like an A5 source, all in one line somehow, and then there was another A5, and then there's a text file. And there, so it wasn't at the right level, right? Somehow things had all gotten scrambled around, and it couldn't find the movie reviews.txt because it was actually an A5/movie reviews.txt, right? Or earlier it was an A5/A5/movie reviews.txt. So again, blaming the computer's not finding my file. No, there's something else that happened, and you don't have a lot of experience to understand all the millions of ways you can make things go wrong, and so that's the hard thing. But you still got to believe that you're the one doing it wrong. Actually, one that is a fairly common error. Someone was like, I am printing out all the tokens in my movie reviews.txt, and it only has the file name that is printing out as a token. So that's crazy, right? How did the file name get into that file? You can open the file and see that it's full of lines of movie reviews. So what happened, do you think? Anyone have a guess?
I did this yesterday, but so I didn't actually convert. The file is as a string, so you're given the name of the file. So when you try to do stuff with it, it just prints out the actual name of that file. You need to actually.
So there was a file name argument in the method, right? And what did you do then?
I just used that.
You made a scanner from it, right? So scanner s equals new scanner file name. And it all looks good because here's the problem. We read file name and we imbue it with other properties than just name or something like that, right? A file name belongs to a file. Well, if you make a scanner out of a string called something.text, the token in this scanner is some.text, right? And you print it out, and that's what you get. You're skipping that file step, right? There's a file equals new file from that file name, and then you put the file in here, right? And actually, the first time, this is by email, also that I looked at that, I was like, oh, that's pretty good, right? Because it's like, you got a scanner, you got a file name, and all that's cool. And it wasn't until he pointed out that it was printing out the file, this itself as the tokens that I was like, oh, wait a minute, now I have something to work with here, right? And I forced myself to go back and review the code, and I realized it was missing, missing this step here. So again, it's not like, your first thought cannot lead to be, my computer has put these words in the file, right? There's something else going on, and you got to break through these assumptions you have, and they're so hard to break through. So again, part of this process is teaching yourself to don't trust yourself at all. Trust the computer. People spend hours wasting time because they're convinced the computer is wrong. Guess what? You are wrong, right? And your code is wrong, and you must learn to accept that. And it's very deflating to realize how bad you are at this, right?
Is there ever an instance the computer is wrong?
Yes, but not in this class. So if you have like a supercomputer with thousands of gigs of memory, and let's say, for example, you built it, there's something called error correcting memory that can deal with some of this stuff. Let's say you build it with that error correcting memory. Gamma rays can come from outer space and zap a bit of memory and actually change a value in there. Like once every, year or something like that. And then the computer's wrong. And occasionally actually there are, when they first released a new version of the Java compiler, it is slightly possible that they have not implemented something correctly themselves, and there's some bug that will quickly be found by the million people using the Java compiler. But the chances that you're the first one to find that bug is like vanishingly small, right? So anyway, it's really hard, but try to get that out of your head that the computer is out to get you with magical, evil intent. You don't need to make voodoo dolls of your computer and poke pins in it and burn things on a fire and all that kind of stuff. You just gotta convince yourself that you're wrong. And the way you do that, of course, is you print out a ton of stuff or use the debugger, right? In this case, with that new int 10, I sometimes ask you to do print lines because it's easier for me to see the output then, and I can tell what's going on. But don't be afraid to put a breakpoint at that line and go into the debugger, and it'll show you the array, and you can look at all the values in it, and kind of convince yourself pretty easily, hopefully. Okay. Any other questions on the assignment before we move on here? Question?
Could you explain the parameters, the process word method a bit better in the Java class bit?
Let's see. What can I look at that's the A5 solution? No. So process words. I remember which one that was. Okay. Convert file to string. Process words. There's a lot of parameters, right? So the basic idea is there are three main arrays we have to be worried about, right? There's words, and it's a really big array of stuff. There is word score. It's a really big array, 14,000 long, whatever it is. And there's word count. It's a big array. And then we're also passing in a scanner. That's some phrase. We want to take all the words out of that phrase and put them somehow into this kind of structure, right? And there's that line score, which is the value of all the words in that scanner. And there is number of words so far, and that's because we're pre-allocating this giant array, but we might only be using 2 spots at first. And the number of words used so far tells us where the next spot is available to start filling in this array. Okay? So basically, let's say we have a scanner filled with me, go. I don't know. That's not very grammatical, right? But I have a reason for picking that. And it has a value of 3. And let's say me was already in this array for some reason, and it had a score of 12. And a count of, it appeared 6 times in previous reviews, and U has a value of 3 and appeared 1 time so far. What this is supposed to do is say, go through all the tokens in the scanner. Me. You decide whether me already exists over here in words. It does, right? You take the value here of this phrase and add it to here. And then you increment the count by 1. We go to the next token, go. Go does not exist in the word list. We add it to the end here. And then we got to move that word so far to the next spot. We've used one more spot in there. The score it gets to start off is this. There's only one thing that it knows about for go, so it uses 3 here. And it has a count of 1. And that's it. You do that for all the tokens, and then at the very end, you have to return this new value used so far or whatever, because that might have changed. And the arrays you don't have to return because we're changing their internals, and so you don't have to return them explicitly. It's a side effect of this function. That's pretty much it. Does that make some sense, or yeah?
So even though we gave the array words like the length of like 16,000, we're not going to necessarily fill all 16,000.
In general, you would not necessarily fill all 16,000. In this particular case, I believe that's how big the array I ended up with, and you should have the same number of words as I do from that movie reviews. If you have a smaller file to test things with, which is not a bad idea, grab 2 of the reviews, put it in a different file, and run your code on that so you can actually track what's going on as opposed to trying to track 16,000 reviews, you know? Then it won't fill it up. It'll only fill up, 15 of those words or something like that. But I believe as a sanity check, you can see if you fill up the array or not, because it should be filled up. Unless I don't think I added like 1 extra just in case or anything like that. But it should be the same.
So for testing, since the array is capped at 16,000, we assume that the movie's review file is going to change.
Yeah. I had originally done something where we were kind of making bigger arrays and copying all the values over and stuff, and then I was just like, yeah, this is already hard enough. Let's leave it alone for now. So we don't have to worry about that. Anything else? So look at this, the slides kind of describe this process a little bit, but certainly if you don't understand this process before you code it, you're really in trouble, right? You have to kind of get why these things are happening. Otherwise, you won't write code that makes it happen because you don't get the process. So work it through by hand like this, see if you can figure it out on some simple case, and test your understanding of what these things are supposed to do for you. That's important.
Is there any reason why the array names have an underscore separating the words instead of just capitalizing?
Oh yeah, that's okay. So, oopsies. My other class I'm teaching is Python, and the standard in Python is to use words separated by an underscore without a capital. More commonly in Java, we do the camel case with a lowercase first letter and uppercase rest of the word, rest of the words. And I think I was working on 2 assignments at the same time, and I just kind of leaked over from Python into here. So now I feel bad. No.
I'm curious now, why does it use underscore instead of camel case?
Why use underscore instead of camel case? Well, I don't know. I think it's more readable. People have strong opinions about this kind of thing, right? Don't think this is like a set issue. People will punch you if you want to do one way, you believe in the other way, So be careful what you say in the wrong crowd. Anything else on the assignment? Yeah.
So if we go through the tester that you provided, like the tester code, and it comes out all green, does that mean you're just good to go and everything's good?
No. I mean, you're in pretty good shape. I deliberately not cover all the possible cases. In fact, I was helping someone yesterday, and I just don't know if it's resolved yet, but for example, my testing case doesn't really hit some of the capitalization stuff too carefully, I think. So it's possible, for example, everything will run and it looks sort of okay, but you gotta be a little more careful. So, and that's what it's deliberate. I want you to think about, you have to outwit the code in some ways, right? And you have to think about what are the things that could cause your code to be wrong, and not just happily write it and hope someone else will take care of it. So anyway, you're in pretty good shape, but you should do something by hand, some small case, and see if you're really doing everything you want. I should try to send out my output, I guess, maybe. You can compare to that, and you can see if you think yours is right. That would be helpful, I'm sure. It's not a test, but it's sort of a sanity check.
Is the canvas, the CPM verify thing, is that basically running the same test that the
CPM verify only says you're supposed to have a method called process words. Is there something spelled process words that takes those parameters? Now, this may seem like a small thing, but to be honest, my TAs are going crazy because before we had the CPM stuff, like half of you are submitting the required method spelled wrong. And so all our tests fail, and they have to go in and hand edit the file and make it work. Like you're not able to copy and paste from the document where I said what the thing should be called and put it in the file correctly. I mean, it's just driving them. That's partly why it's taking forever for them to grade, because instead of it going through and pass all these tests, now some class would just say, they passed no tests, 0, you know, kind of thing. But we're trying to help you out and look for typos and fix those things. But it's kind of super unprofessional that you can't even hit the level of spelling the method name correctly. You know, that's not going to cut it in the future. So you got to step it up a little bit here. And again, I know I'm talking to the people here that are attending class, and you're probably all doing a good job. But these things are, you know, basic literacy is important, and cutting and pasting capability is important. So verify just says
all the methods that were asked for and they're spelled.
It doesn't run any tests at all. It just says, can I compile, like, will it compile this like basic thing without dying?
So
it's not doing much for you, but it's doing more than it's doing more than you think might be necessary. Okay, we better move on a little bit here. So, for those of you who've been spending hours and hours and hours, now you get another day to spend more hours and hours and hours working on the assignment. Yeah. But ask for help. Don't get stuck forever. Okay. All right. So we looked at search, and we did sequential search, which looked at every item in order. And using that big O notation, we would say that sequential search is big O of n. If the array is n items long, we have to look in the worst case at all those n items, right? That's how you tell for sure that something is not in that array. Is this name David? 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 Until you look at all of them, you can't guarantee that David's not in there, right? So this says as the array length gets bigger, the time takes grows at the same difference. It grows linearly. So in some ways, it sort of feels like that's the best you can do to tell if something's in there or not. You got to look at all the items, right? But maybe we can arrange the data to make it easier to search. So there's something called binary search. And what it wants is an array that has been sorted from lowest to highest in the array. So there's a step before you can call binary search. And we don't know how to do that yet. There is a Java sort on arrays you can call, and sort of magically makes things happen. But with binary search, you can now do more efficient searching than looking at every possible item. So let's say I look at the value for stored at index 1 on this sorted array. What can I say about the array once I know this value here? So I've only looked at one thing. I only looked at 4, right? So what can I say?
Everything for n is equal or greater than, and everything less before it is less than.
Yeah, because it's sorted. I can say we know everything to the right is bigger than 4, or 4, depending on if there's repeated values or not. And everything to the left here is smaller or equal to 4, right? So you can make some kind of decision about where in the array a certain value might be. If I'm looking for 12, should I look on this side or look on this side of that value? Right? If I'm looking for 12, it's bigger than 4, so it's got to be over on this side of the array, right? I can ignore, I never have to look at the 2, because I already know everything to the left of the 4 is smaller than 12. All right, so sorting lets us make some kind of decisions about where items may lay in the array. Now you can't say for sure, you know, if you're looking for 12, you can't say, oh, there's 24 spots, so it's probably right in the middle, because you don't know if the data is negative 1,000,000, 100, 200, 300, 400, or whether it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, you know, to 24. You don't know what the data looks like necessarily, but you do know, given one value in the array, whether things are bigger on the one side or smaller on the other side. Okay? So you get that? That once you peek at one spot in the array, you can make some sort of guess as to where the thing you're looking for lies. So using that, we can search more efficiently. Let's say we're looking for the value 2. Now this is a little confusing because this is index 2, right? So I'm looking for value 2. I want to start in the middle of the array here. I'm going to, however big it is, I'm picking the one in the middle. Now where would the value 2 be? On this side or this side? On the left side, right? Now you're cheating because you're looking at the value 2 over here. But you know that just because it's sorted. You know that 2 is smaller than 7, and so we can ignore this half of the array, right? So once I know that, what should I do next? I should look at another value here on the left, over here, and see if that's 2 or where 2 is going to lie relative to it. So I can throw away, essentially, the value I looked at, plus all the stuff to the right of it, because those are not going to contain 2. There's no way, if it's sorted, it can contain 2, because 2 is smaller than 7, right? So it would not be sorted if that's the case. So we throw all those away. We have this remaining part of the array we look at. What's the middle of these 2 values? What should I choose if I always want to pick something in the middle? I don't want to pick my index 0.5 because there is nothing there, right? I have to decide to either round up or round down at some point. Let's say I round down to index 0. I'm going to call that the middle of these 2. And that's the 2, and I found it. So in order to find the 2, I had to look at 1 value, 2 values, but I did not have to look at 5 values, right? So I looked at fewer values than there were in the array, and I still managed to find my item. Now, we're worried about the worst case, not really just I got lucky and found a 2. So let's imagine the same process looking for a value of 3, right? So if I want to find a value or a key, what we call a key, of 3, I'm going to start in the middle. It's a 7. 3 is less than 7. Throw all that away. Look at these 2. Pick this one here. 2 is less than 3. So I know it's not here, but it could be to the right of it. So I'd throw that away. I'd look at this one. 4 is also not 3. But now I've thrown away everything, basically, and there's nothing left to look at. And I looked at 1, 2, 3 items in the array in order to prove that some item was not found in the array. Whereas before, with sequential search, to prove something was not in the array, we had to look at every item, right? So I'm doing better than this linear big O notation. All right, so let's just try a couple random examples showing sort of how this works again. So if I have 1, 5, 9, 11, 21, 27, 32. How are these all spread out weird? I can't tell what's a number and what's a... Okay. Where should I start looking on this array? Let's say I'm looking for key equals 27. I should look right here, right? No. That's cheating. I already knew that. Where should I start?
Just a quick question before we answer that is, if they're not sorted numerically, is there a way to do that? Or
Yeah.
we're just making an assumption if they are?
Well, we're making that assumption, but
We'll learn later.
typically the method will assume the values coming in are sorted, and then it's up to you to sort them in advance. And I'll show you this array sort thing. It's very easy. So where should I start looking here, do you think?
11, middle.
So we have to talk in index terms, right? We can't really say what value we want to look at, but you're right.
3.
The middle, right? And why the middle? Why not, why not something off to the side a little bit more? Do you think? Yeah?
Middle cuts off half of the numbers available. So you don't, if you have like 10, you cut it to 5, and then it cuts it smaller, so you don't have large amounts.
Yeah, it's like that guessing game thing, right? When you're a kid, you do that guessing game, like guess a number between 1 and 100. You start off and you say 10, right? And then you say 12, and then you say 14, and then you keep saying bigger, 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 and then they finally get, 75, and then lower, 45. You don't have a real pattern to it. But at a certain point, we all kind of snap in that the most efficient way to do that is to have the options each time. Now, it doesn't necessarily, like you can get lucky picking this location first or something like that, and maybe that happens to be what you're looking for, but in general, if you want to just play it safe, conservatively, you always start in the middle and subdivide in half each time. So we follow that same strategy. We pick the middle one. We say, is 11 equal to 27? No, it's not. Is 27 bigger than 11? Yes, it is. If 27 is bigger than 11, what can I throw out here? I don't have to look at any of those values. They're all smaller than 11, and we know our key is bigger than 11. Right? Now make sure, in some ways, some of you want to keep the 11 around and just throw away the stuff to the left of it. We already looked at that. We know that's not the answer. So throw out that one as well. Okay? So here's my remaining array. And I want to pick the middle of that, right? And we can kind of do that visually. So that's the middle one. I'm looking for 27. Is it 27? It is. I found it. Yay! Right? So 2 steps, I've managed to find it. This could work on other kinds of data. I could have strings, an array of strings. And we know we can arrange those because you already used that lexicographic ordering from the last assignment, right? And so we can arrange them in some ascending order. And we can do the same kind of search. We're looking for eagle. We start in the middle. Where should I start in the middle here?
1.
It doesn't really matter. This would be consistent, right? So we're going to say this one's the middle. We're going to round. This is really the middle here, right? We're going to round down or something like that. So we look here for cat. Eagle is bigger than cat. We throw those out. We look at these two. We pick this one as the middle. Dog is not eagle, but it's also less than eagle. We throw out everything to the right. Oh wait, throw out everything. That's the wrong way. I just wanted to be done there. We throw out everything to the left, and this is the only thing left. That's the middle. Fish is not eagle. We throw it out. Nothing left, and so we didn't find it, right? Binary search isn't that good. It's not there. Okay, so let's implement binary search. Now this is a little complicated. There's like you're looking here, and there's like things you're throwing away, and it's it's like how do you do this sort of reasonably? So this is a good place where you learn how to like break down problems in your head into steps, solve the steps, and then you solve the whole thing, and you're all good, right? So there's 3 things we need to worry about during the search. So when we have a key and we have an array, and we know where we're looking in the array, what are the 3 possible cases when we look at that middle value?
It's either it.
It's it, we found it, or it's less than it, or it's bigger than it, right? So once we sort of think about, here's our breakdown. There's 3 things we have to worry about, and if we cover all those cases, there's nothing else to worry about. So, that's the key there. You got to figure out how many possible things you have to worry about, and then you solve them all, and then you're kind of done. So there's 3 possibilities. Another way decomposing it is there's like stages of this process. We do the middle one, we look at it, we make some decision, throw some stuff away, and then we do it again, right? So if we can solve it for one step, we can probably put that in a loop and then solve it for all the steps. And so again, don't worry about kind of solving it all at once. Think if I can go from the whole array to half the array, and then I'm kind of in good shape. Now the real issue I think with this is how to represent this shrinking array. So one thing we could do is look for that middle one, throw stuff away. We have some that's left. That array copy method is actually pretty general. You can say like copy from index 5 to index 8 and copy it into some other array. So I could form like a whole new array each time if I wanted to and work now on that smaller array and not kind of worry about it. But what's kind of a bad thing about doing this kind of approach, do you think? What do you think?
Now we've lost what we call original index position because...
Yeah, so if I'm looking for 18 and I find 18, I'm going to say it's at location 1 here, not at location 6, right? So we sort of lost our answer almost. So we could say it's there, but we be harder to figure out where it is. What else is wrong with this idea of making a new array to represent that half that exists?
It can take up a lot of memory.
Take up memory, but even more so, time. It takes time to copy that over, right? And I was claiming one thing about binary search is that we're going to try to avoid this big O of n cost of doing this. But what do you notice about the copying process? I have to look at every element to copy it over. So if there's n elements in this array, I'm copying over, well, n divided by 2 in this case, but I still am basically touching all the elements in order to copy them. So then I'm sort of cheating to say that I'm only looking at 3 values, but I still have to look at all of them to move them over, right? So I'm not really getting any speed benefit here.
You also don't know how many arrays you have to create.
Yeah, but you could keep reusing the same int array variable and just stick smaller and smaller arrays onto it.
Oh.
So you could sort of, you don't have to kind of plan it out in advance, array 7, array 6, array 5 kind of thing. So we don't want to do this copying. So instead, we're going to use index values and kind of keep track of what is a valid part of the array still. And this is actually very close to that word count thing where I said, here's the number of words I've used so far, and I used a number to say where the end of that array is. So we're going to use a MinIndex that says these are the values we're interested in starting here and going to the right, a max index, that's the highest index we can use, and as we throw away half of the array, we're going to change MinIndex to scoot up and say, this is where we're going to start looking at values. Okay, so when we first start with our big array, we have a MinIndex and a max index, and we figure out the middle index based on some of those values. And then if we're looking for 18 in this case, the middle value is 6. That means everything to the right is where it possibly could be, not to the left. And so we're going to move MinIndex to one class past the middle, saying this is where the values that may contain 18 start. Okay, so these indices are basically reforming the valid parts of the array with those numbers, even though the whole array still exists. Okay, so think of these as like little pinchers that are, this is the start, this is the end. We shrink again, this is the start, this is the end, right? They kind of collapse in on themselves, and eventually they squeeze down to nothing or to the actual item. Questions about that? So we're not changing the array, we're just changing numbers that say which part of the array still may contain the answer. Okay, you got to, and that's what it means. You have to kind of hold that, meaning in your head. There's nothing in Java that says this means something special. It's just our code. We're agreeing that those values are meeting the valid range of the array we're using. Okay, so let's write some code, I guess. In class code lecture 17. Okay. So I'm going to make an array. All right, that took a long time. An int array of vals, and I'm going to initialize it. I want to have some sort of more interesting values than sort of just zeros. 2, 4, 2, 8, 9. So I'm going to want to find things in this array. Now, what do I need to do before I can use binary search on this? I need to sort it, right? So there is arrays.sort, sort vals. And it's complaining to me, I don't know about arrays, so import arrays. Yay, thank you, Eclipse. Okay. And if I were to print out arrays to string vals, hopefully we will see that it's now sorted. So I can run this, and it sorted it. Okay, so that part was easy. Now, it's actually doing work there. So it's not for free, but we don't have to code it. And now I want to find a value. So I want to get out some index location that says where the value I'm looking for is. And I'm going to search for some key in vals and give it some value I'm looking for. So my hope is that this method, given an array, a sorted array, and a key value will say where 5 is located in that array, if it exists, right? So now we have to implement that. So I'm going to make a public static. I'm returning an index value, so I'm returning an int. And I'm calling this binary search for key. And it works on, I'm going to call it nums as my parameter. And it has to, of course, have a type. That was more Python leaking through there where you don't have to do that. And a key value. Okay. It's complaining that I don't have a return value right now, so I always want it to just give me a minute here, right? Just hold off. Be cool. Okay, so when I first start off, I have my low index. And what is the valid start of the array in terms of its indices? When we first begin? 0, right? All the way to the left. And I have a high value. And what should that one be? Well, if you say 8 and then I do that, that's not going to be right anymore, right? So, yeah, how many values do we have in here? We have 1, 2, 3, 4, 5, 6, 7, right? 8 would be wrong anyway. So there's 7 values in this array, which means the indices go from what to what? 0 to 6. And if I ask nums how long it is, what number am I going to get back? 7 in this case, right? So if the top valid index is 6, that's 1 less than the length of the array. And this is kind of the kind of stuff, to be honest, that will kind of drive you crazy a little bit trying to do array stuff. So you're counting from index 0. And so all these things are always like, you're always shifting something by 1 somewhere to kind of make it work out, okay? So the length of this thing in our test case is 7. The indices go from 0 to 6, so we need to subtract 1 from length in general to get the top index. If there's 10 values, the top index would be 9, and so on.
What would it do if you forgot the 1? Like, what would the error be?
Here, it would probably try to access a value off the end of the array and throw an exception. Or at some point do something like that. Now, let's just kind of try to do one stage of this process. In other words, let's find the middle, and then see what's bigger or smaller on it, right? Let's not solve the whole thing at once. Let's see if we can can we do one stage of this process. So we want another value mid. And this is sort of the tricky part in some ways. Where, it's all covered with scratches now, so it's a little hard to tell. How do I figure out what index is the middle of this array?
Minus low over 2, take the 4.
So maybe it's good first to figure out what the middle is, right? The middle is index 3. So we had in this particular case right now we have low is 0, high, this is just to kind of make this line up. That's not how you spell high in terms of upper bound, right? High is 6. And we want to somehow turn that into a 3. I feel like I started doing some other weird math than what I want to do right now. What I decided to do was to compute the length of the array we're interested in messing with, which is not nums.length because we're going to start shrinking this thing down, right? So I'm going to say our valid length is high minus low plus 1. In other words, we're kind of going back. To get high, we did the length minus 1. So to kind of get the length back for this stuff, we have to add 1. All right? So high is 6, minus 0, plus 1 is 7. That's the length of the array right now. And then to find the middle one, we're going to say start at low and go half the length. Okay? So the middle equals the length divided by 2 plus the low value. Because the low value might be here, and then we've got to figure out how far to go starting at that location here.
You mean valid length?
Yeah, valid length, really. Valid length, yeah. I just want to fit it. And there's different ways to think. You can think about averaging the high and low and all sorts of different ways to think about it, right? That's the way I kind of wanted to think about it. So I'm going to make an int valid length equals high minus low plus 1. And then the middle equals the low plus valid length. Here I go again. Valid length divided by 2. What's going to happen if like my valid length is 3 and I divide by 2? What kind of answer am I going to get out of that?
Won't it round down since you're dividing an integer?
If this is an integer and this is an integer, it truncates the result. It rounds down basically, right? And that's okay. So we're deciding that the middle one, if it falls in between two of them, we're going to round down. All right, now, not have much time I know, I'm going to check my 3 cases. If nums at mid equals key, what should I do? I'm done. Return that index, right? I don't have to look anymore for stuff. If nums at mid is bigger than key, in other words, the thing I'm looking at is bigger than the key, what does that mean? Which part do I want to throw away? If the middle is bigger than the key, I want to throw away all that stuff, right? How can I throw it away? I want to move high, right? So if that's true, I want to say high equals, is that middle one a valid value? It's not I already know it's not my answer, right? So I actually want to make it mid minus 1. If nums mid is less than key, that means, I look here, this is too small. That means I want to throw away this side. How do I throw away that side? I change low. Mid plus 1. Right? So I'm sort of moving, I'm either moving the high down or the low up, and it's getting rid of half of the array at a time. All that's left is to loop a couple times and we'll be done, but we'll do that next time.